Okay, today we're going to talk about how to construct a heating curve using information from an experiment. We have time is always going to be on the x-axis because as time increases, the average kinetic energy is going to also increase. Now, like I told you before, don't have to say kinetic energy, you can also say temperature. They're interchangeable. They mean exactly the same thing. So do not get confused if you see kinetic energy. Also, if you see the word energy on the side, same thing. Now, if we take a piece of ice at time point 0 and increase the temperature over time, what's going to happen is you're going to notice that the ice is going to actually heat up until it reaches 0 degrees. Then you're going to notice it takes a long time where a lot of time changes, but the temperature doesn't increase. Then it will melt, become a liquid. It will increase in temperature again, and then it will plateau again. Then eventually, after more time, it will start rising again. So this is what a heating curve looks like. It can also be a cooling curve if you reversed it. So this is just a piece of ice warming up. Once that ice reaches the temperature of 0, it's actually going to be melting. But it's not going to be exclusively in the liquid phase. It's going to be a combination of liquid and solid. So this is considered to be melting. Now, after a certain amount of time, it's going to be all melted. So it's all going to be in the liquid phase. Where that temperature is going to heat up and keep increasing. Now once it starts boiling, there's going to be another change of phase, and some of the particles are going to escape the liquid phase and start to change into the gas phase. This is considered the boiling point. And finally, once all the liquid is in the gas phase, that liquid or that gas will continue to heat up, and the temperature will continue to rise. So two things to pay attention to. We have the green lines here, and we have the purple lines, correction, red lines. Now, at the green lines, what's happening? The temperature is increasing. Green line equals temperature increase. So all the energy is going into making these particles move faster. Particles are moving faster, particles are moving faster. But now as we look right here, we have something where it's actually the temperature is not increasing. It's staying level. So what's happening here? This is the phase change. So instead of the temperature actually increasing, the extra energy is going to change it from a solid to a liquid, or from a liquid to a gas. In other words, this right here takes energy. This is happening at this phase. At this phase, for boiling, it is going from this to this. This is where all the energy is going. So we're not actually increasing the temperature. We're not actually increasing the speed of the particles. We're just changing their orientation. So the things you need to pay attention to is 1, 2, 3 segments, the temperature is increasing, and 1, 2 segments, it is a phase change. This is boiling. It could also be condensing, or in other words, the condensation point, and this could also be the freezing point, if you're going the opposite direction, from warm to cold. Okay? You know what to do. Practice problems. Peace.